Hello everyone and welcome back to study room. I hope you all are doing great. So today we will be doing some questions on linear conservation of momentum. So let's get started. So before we start with the questions, let's revise the concept. Okay. So what did we know? That your momentum is always conserved. Correct. We learned about the conservation of momentum. So if we have a system of two objects, okay, so there is one object which has mass m1, another object which has mass m2, okay. If the initial momentum of m1 is m1 u1, right, u1 is the initial velocity of m1, okay, and initial momentum of mass m2 is m2 u2, okay. So for mass m2, u2 is the initial velocity. Then what will be the final momentum? For instance, m1 has the final momentum as m1 v1. v1 is the final velocity of m1. And for m2, it has final momentum as m2 v2. v2 is the final velocity of m2. Okay. So what are we saying? That the initial momentum and the final momentum, total initial momentum and total final momentum will be same. Okay. So we are saying that there is no loss in momentum. Momentum can neither be created nor be destroyed. So let's do its applications and apply it in some questions. So let's get started. Our question is, a bullet of mass 20 grams is horizontally fired. Okay, we have a bullet. Okay, it is horizontally fired with a velocity of 150 meter per second from a pistol of mass 2 kgs. Okay, so we have one bullet. Let's say its mass is mb. Okay, and mb is equals to 20 grams. Okay, 20 grams is how much? 20 upon 1000 kgs. Okay, so we need to convert it into kgs. Don't forget the SI units. Okay, so and the mass of the pistol, let's call it mp. Okay, mass of pistol is mp and it is given to be 2 kgs. What is the recoil velocity of the pistol? We need to calculate the velocity of pistol, recoil velocity. Okay, recoil velocity, what does that mean? That after firing, what is recoil velocity? After firing, when you fired, so when you fired, there is some velocity which is attained by the pistol, okay, after firing. So what is that velocity? That velocity is known as recoil velocity. So let's solve this question. Mass of bullet mb is equals to 20 grams, correct, that is 0.02 kgs. Mass of pistol is 2 kgs. Okay, so mass of pistol is 2 kgs and mass of bullet is 0.02 kgs. Let UB be the initial velocity of bullet. So let's give the name of the initial velocity of bullet as UB. Okay, so UB is the initial velocity of bullet and let the initial velocity of pistol be UP. Okay, so this is your pistol. Your bullet has some initial velocity UB and your pistol. So for your pistol, the initial velocity will be 0. Why so? Because you are holding the pistol in your hand, so it has no velocity, right? So UP is equals to 0. Okay, VB is velocity of bullet, right? Velocity of bullet is 150 meter per second. It is given, right? Plus 150 meter per second because direction of bullet is from left to right. Okay, we are taking it. Let V be the recoil velocity of pistol. Okay, so before firing, what will be the total momentum before firing? You tell me, since our whole system of bullet and gun is at rest. Okay, since our whole system of bullet and gun is at rest, so our velocity is 0, right? So we'll just do take the initial momentum. It will be what? m1 u1 plus m2 u2, right? So m1 is your what? It is your mass of pistol. So in this case, it is mp up plus mb ub, right? Now your UP is also 0 and UB is also 0 because initially your system is at rest. You are holding the pistol in your hand, right? So what is your initial momentum? So 2 into 0 plus 0.02 into 0, which comes out to be 0 kg meter per second. This is your initial momentum. Okay. So after firing, after you have fired, like the pistol has now come out of the bullet has now come out of the pistol. Okay, so total momentum of pistol and bullet after it is fired. How much is the total momentum? We know 0.02 kg is the mass of bullet. Okay, so 0.02 kg into 150. Why 150? Because it is mass of bullet into velocity of bullet. Velocity of bullet is plus 150 meter per second because bullet is fired from left to right, okay, plus mpvp, correct. Mass of pistol into velocity of pistol. Now mass of pistol is 2 kgs and velocity of pistol you need to find, okay. So this is your final momentum, correct. This is your final momentum, which comes out to be 3 plus 2 vp, okay. According to law of conservation of momentum, your total momentum remains conserved. So your initial momentum is equal to your final momentum. What was your initial momentum? It was 0. What is your final momentum? 3 plus 2 vp, right. Vp is your recoil velocity, right, velocity of pistol, right. So 3 plus 2 vp is equals to 0, which implies v is equals to minus 1.5 meter per second. So you can see this minus sign denotes that velocity of recoil velocity is in opposite direction. If bullet was fired in the right direction from left to right, so your recoil velocity is from right to left, right. That's why when you do firing, your hand moves a bit in left side, right, backwards. Why so? Due to recoil velocity, okay. This is due to conservation of momentum. So to conserve momentum, we need to have some velocity of pistol as well, okay, which is minus 1.5 meter per second. So it is 1.5 meter per second in the opposite direction, okay. So this is how we found the velocity using law of conservation of momentum. So let's look at one more question. A girl of mass 40 kg jumps with a horizontal velocity of 5 meter per second onto a stationary cart with frictionless wheels, okay. The mass of cart is 3 kgs. What is her velocity as the cart starts moving? Okay, so mass of the girl is 40 kgs, mass of girl 40 kg and initial velocity of girl is 5 meter per second. So this is a system of girl and cart, okay. This is also a 2 object system, okay. So and what is the initial momentum of the girl? It is 40 into 5, that is 200 kg meter per second. This is the initial momentum of the girl. Okay, and if we talk about the stationary cart means at rest, okay. So it has no initial velocity. So what will be its initial momentum? It will be 0, right. Now mass of cart is 3 kg. What is their velocity as the cart starts moving, okay. So now what will be the final momentum? Final momentum will be mass of girl plus mass of cart, because now they both are together into velocity, right. And what are we supposed to find? We are supposed to find this velocity, right. So of course our momentum remains conserved, right. So let's do this. Let mg be the mass of girl, okay, is equals to 40 kgs. ug be the initial velocity of girl, 5 meter per second. vg be the final velocity of girl. So similarly, let mc be the mass of cart, uc be the initial velocity of cart, and since the cart is stationary, your initial velocity is 0 meter per second, and vc be the final velocity of cart, which is, let's say it is v, okay. So total momentum of girl and cart, like this system before interaction, okay. What is initial momentum? mg ug plus mc uc, right. So what is mg ug? Mass of girl into initial velocity of girl, right, 40 into 5 plus mc uc. So you know, since the cart is stationary, so initial velocity is 0, okay. So 3 into 0. So this comes out to be 200 kg meter per second. This is your initial momentum, right. Initial momentum, okay. Then total momentum, okay, one thing, momentum is singular, okay, when we are talking about just one object. But if we are talking about like a system, so it is momenta, okay, and momenta is plural, okay. So keep this in mind. Total momentum of girl and cart after interaction, okay. So after girl and cart meet, okay, girl is on the cart now, so their mass gets added and this is your final velocity, right. So mass of girl is 40 kgs, mass of cart is 3 kgs, okay. So what is their total mass? 40 plus 3, that is 43. And let's say that their velocity be v, their final velocity, right, 43 v. So it comes out to be 43 v. It is your final momentum. So according to law of conservation of momentum, total momentum remains conserved, okay. Initial momentum is equals to final momentum, yeah, right. So 43 v is equals to 200. 200 is your initial momentum, 43 v is your final momentum. We just equated, and this is how we find that v is equals to 200 by 43 is equals to plus 4.65 meter per second. So now you see, in this case your momentum turns out to be positive. What does that mean? That girl would move in the direction in which the girl has jumped. Okay, let's do one more question. two hockey players of opposite teams, while trying to hit a hockey ball on the ground, collide and immediately become entangled. So these are two hockey players. See, they are in opposite direction, right? So this player is towards this direction and this player is towards this direction. Okay, you need to note if we are in opposite directions. So of course, the sign of velocities will be, one will be plus and other will be minus. Okay, so do remember these things. Okay, one has a mass of 60 kgs and was moving with a velocity of 5 meter per second, while the other has a mass of 55 kgs. So okay, it was moving with a velocity of 6 meter per second. This is moving with a velocity of 6 meter per second. Okay, towards the first player. In which direction and with what velocity will they move after they become entangled? Okay, assume that the frictional force acting between these players is negligible. Okay, so we are considering that frictional force is negligible. If it wasn't negligible, then we had to take into account this force as well. Okay, so let's do these questions together. Okay, so let's name these players as player 1 and player 2. Okay, these hockey players. Okay, two hockey players now. So let's say that P1 and P2. Okay, so let's find their initial momentum first. Okay, so what is the total initial momentum? Okay, so for, let's say for P1, for player 1, let its mass be m1 and its initial velocity be u1. Okay, and for player 2, mass is m2 and initial velocity is u2. Okay, so what is the total initial momenta? What is it? Simply it is m1 u1 plus m2 u2. Correct. So let's quickly see this. What is the mass of the first player? 60 kgs, and he is moving with a velocity of 5 meter per second. Okay, so our m1 is equals to 60 kgs and 60 kgs and our u1 is 5 meter per second. Similarly, what is our mass of the player 2? It is 55 kgs and he is moving with 6 meter per second. Okay, so our m2 is 55 kgs and he is moving with 6 meter per second. Okay, so what is our total initial momentum? It is 60 into 5 plus 55 into 6. Okay, let's calculate it quickly. Okay, now one very important thing to notice is that we are seeing that both the players are acting in opposite directions. See, so if we say that this player 1 is acting in this direction. Okay, so plus 5 meter per second. Okay, so what is the velocity of the player 2? He is acting in opposite direction. He is acting from velocity is from right to left direction, so it is minus 6 meter per second, right? We have to take direction in account. Okay, when we are talking about velocity, right, it is a vector quantity. Magnitude and direction both have to be seen. So m2 and what will be our u2? It will be minus 6. Okay, so let's do it. 60 into 5 is 300 plus 55 into 6 is minus 330. Okay, so what does it come out to be? It comes out to be minus 30 kg meter per second. This is your initial momentum. Okay, so let's calculate the final momentum. Now what will be the final momentum when these two players got entangled, right? When they both came in contact with each other. Okay, so final momentum, what will it be? Final momentum will be m1 plus m2. This will be our total mass of the final momentum, right? And let's say that the final velocity of this system is v. Okay, so from law of conservation of momentum, we know that initial momentum is equals to final momentum. Correct. So what does that mean? That minus 30 is equals to, what is your m1 plus m2? 60 plus 55. Okay, what is 60 plus 55? It is 115. One second. Okay, so it is your 115. Okay, m1 plus m2, 60 plus 55 is 115v. Okay, so now v is equals to 115 upon minus 30. V comes out to be minus 0.26 meter per second. So this will be the velocity with which they will be moving. And in which direction will they be moving? You tell me, because it is minus sign. So your resultant momentum, it is in towards right, from right to left, towards left, okay. And this is very logical. I'll show you how. So see, so your initial momentum for player 1 was how much? 300, okay, 16 to 5, right? And your initial momentum for player 2 was how much? How much was it? 55 into 5. It was 300 and how much? Let's calculate it quickly. No, its initial velocity is 6, no? So 55 into 6, okay, how much it is? It is equal to, your initial momentum for this player 2 is how much? 55 into 6, which is 330, okay. So we can see that this player has a dominant momentum, right? So momentum of this player is 300 kg meter per second, and momentum for player 2 is 330 kg meter per second. So he has a dominant momentum. What does that mean? That your final momentum will be in favor of player 2's direction, okay. So as you can see, it comes out in the direction from right to left, okay, as we just calculated. So it comes out to be negative, and negative sign indicates that velocity is in direction from right to left, okay. I hope it's clear, okay. Let's do this question. If action is always equal to reaction, explain how can a horse pull a cart, okay. So we know that, we know from Newton's third law that for every action there is an equal and opposite reaction, correct? This is so interesting, right? This is true in our life also. For every action there is an equal and opposite reaction. If you do good, you get good, right? Okay. So this only Newton's third law, this principle is only acting in this question, right? So a horse pushes the ground in a backward direction. According to Newton's third law of motion, for every action there is an equal and opposite reaction, right? When the horse walks in the forward direction with the cart attached to it, it exerts a force in the backward direction on the earth, right? So when the horse is, moving in the forward direction, okay, so he is exerting the force in the backward direction. Why? Due to Newton's third law of motion, because for every action there is an equal and opposite reaction. So an equal force in the opposite direction is applied on the horse by the earth. This force moves the horse and the cart forward. As a result, the cart moves forward, okay. So simply we are applying Newton's third law of motion, okay. Let's do this. Explain why is it difficult for a fireman to hold a hose which ejects a large amounts of water with high velocity. Again, same principle. For every action there is an equal and opposite reaction, correct? So that's why it is difficult for a fireman to hold a hose, right? Because what happens? When a fireman holds a hose which is ejecting large amounts of water at a high velocity, then a reaction force is exerted on him by ejecting water in the backward direction, right? So there is an equal and opposite force which is acting in the backward direction. This is because of Newton's third law of motion. As a result of the backward force, the stability of fireman decreases. That's why it is difficult for the fireman to hold the hose, right? Let's do this question. From a rifle of mass 4 kgs, a bullet of mass 50 gram is fired with initial velocity of 35 meter per second, okay. So we have that, like, mass of rifle is 4 kgs, okay. And what is the mass of bullet? Mass of bullet is 50 grams. That is how much kgs? 50 by 1000 kgs, correct? So this is your 0.05 kgs, okay. Don't forget to convert it into kgs, okay. SI units are very important, okay, correct. So so it is fired with an initial velocity of 35 meter per second. What is the velocity of bullet? It is 35 meter per second, okay. So for rifle and for bullet, so this is a two object system, two particle system of bullet and rifle, right? So this is our system, okay. So we'll calculate the momentum, right? We have to calculate the initial recoil velocity, okay? So let's do this together. So let's calculate the initial momentum, and then we'll calculate the final momentum, and then we'll equate them. Okay, so this is similar to the question which we did earlier, okay? And then we'll calculate final momentum, and then we have to just equate them because of law of conservation of momentum. Momentum can neither be created nor be destroyed. So your initial momentum of the rifle and this bullet system before firing, your initial momentum will be before firing, and your final momentum will be after firing. So we need to calculate the initial momentum and the final momentum, and we will equate them, right? So what is your initial momentum? Mass of rifle into initial velocity of rifle plus mass of bullet into initial velocity of bullet. So we know for bullet and rifle system, our initial velocity is rest, because initially the bullet and the rifle is at rest, right? You are holding the rifle. So your initial momentum comes out to be 0 kg meter per second. For final momentum, we need mass of rifle into final velocity of rifle, right? Plus mass of bullet into final velocity of bullet. Correct. So what does it come out to be? So your mass of rifle is 4 kgs. And what is your velocity? It is V, right? We need to find out the recoil velocity of rifle. Plus, what is your mass of bullet? 0.05 kgs. And what is your velocity of bullet? It is 35 meters per second. Okay, so we just need to equate both of these because our momentum remains same, right? There is no loss. There is no loss of momentum, right? So 4V plus 0.05 into 35 meter per second is equals to 0, right? Because initial momentum is equals to final momentum. So V is equals to 1 minus 1.75 by 4. So this comes out to be, one second, minus 0.4375 meter per second. Okay, so this is your recoil velocity. What is that? Minus 0.4375 meter per second. So this negative sign again, what does this indicate? This indicates that your velocity is in opposite direction, right? For your pistol, for your rifle, bullet is in this direction, so your recoil velocity is in this direction. Okay, that's why whenever you shoot, you have a force which is acting in the backward direction. Okay, you feel a force acting in the backward direction, a recoil velocity. Okay, so this is how we'll calculate. So what is the principle which we are applying? Nothing but law of conservation of momentum. Law of conservation of momentum. That is your momentum before collision, and momentum after collision is conserved. Okay, let's do one more question. Okay, two objects of mass 100 grams and 200 grams are moving along the same line and direction. Okay, so we have two masses which are moving along the same line and direction. Okay, both are moving in the same line and same direction with velocities 2 meter per second and 1 meter per second. They collide, and after the collision, the first object moves at a velocity of 1.67 meter per second. Determine the velocity of second object. Again, what are we supposed to do? We have to conserve momentum. Correct. So firstly, we'll calculate momentum before collision. What will it be? So since it is 100 grams, firstly we'll convert it into kgs, correct? So this is 0.1 kgs. Okay, your m1 is equals to 0.1 kgs. What is your initial velocity u1? u1 is equals to 2 meter per second. So what is your mass of second object? m2 is equals to 0.2 kgs. What is your initial velocity u2? It is equals to 1 meter per second, correct? So what is your momentum before collision? It is the addition of m1 u1 plus m2 u2. Total momentum before collision is m1 u1 plus m2 u2, which is equals to 0.1 into 2 plus 0.2 into 1 is equals to how much? 0.2 plus 0.2 is equals to 0.4 kg meter per second. Okay, so now let's calculate the final momentum. like after they collide, the first object moves at a velocity of 1.67 meter per second. So for your first object, your final velocity is how much? 1.67 meter per second. And we have to calculate the velocity of second object. We have to calculate the velocity of the final velocity of the second object. What are we supposed to do? So what is your final momentum? Your final momentum is m1v1 plus m2v2. Correct. How much is this? 0.1 into what is your v1? 1.67 plus 0.2 into v2. Right. So this is your initial momentum. This is your final momentum. Now what are we supposed to do? We have to apply law of conservation of momentum simply. Right. So we'll say that 0.4 initial momentum is equals to final momentum. Okay, so 0.4. So momentum before collision is equals to momentum after collision. Okay, we just have to equate this. Okay, so we'll simply equate it. So what is the initial momentum? 0.4, right, is equals to 0.1 into 1.67 plus 0.2 into v, right? So what is your v? V is equals to how much? 0.4 minus 0.1 into 1.67 upon 0.2, and this comes out to be how much? It comes out to be 1.165 meter per second. So what is the velocity of the second object? It is 1.165 meter per second. Okay, isn't that simple? You just have to apply one principle and you are able to solve all the questions, right? What is it? Law of conservation of momentum. Momentum always remain conserved. Okay, so momentum before collision and momentum after collision is equal, right? Momentum can neither be created nor be destroyed. So let's quickly revise, okay? So firstly, we studied about first law of motion. An object continues to be in a state of rest or uniform motion along a straight line unless acted upon by an unbalanced force. So this is your law of inertia, right? What was your inertia? Tendency to remain at rest if you are at rest and remain moving if you are moving, okay? So the natural tendency of objects to resist change, right, in their state of rest or uniform motion is called inertia. Force of friction always opposes the motion of objects. For example, for your object, if force is applied in this direction, friction will always act in the opposite direction, and friction is denoted by small f, okay? Then we studied about second law of motion. Okay, so what does it state? That rate of change of momentum is proportional to the force applied. Okay, so force is proportional to rate of change of momentum. Okay, so force is equals to k into m v minus u by 2 t, and your k appears to be 1. So force is equals to mv minus mu by t. Okay, further, the momentum of an object is the product of its mass and velocity. So we denote momentum with p, and it is the product of mass and velocity, and its SI unit is kg meter per second, right? Third law of motion, then what does that say? It is my favorite, right? Third law of motion. For every action there is an equal and opposite reaction. Okay, in an isolated system, if there is no external force, the total momentum remains conserved. Correct? So with this we came to an end of this chapter. I hope you all have understood, and this is a really very interesting chapter. And do revise, do ask doubts, and have a nice day. Stay safe.